ladies and gentlemen, and dear friends. I am extremely thankful to the Institution of Engineers India for the honor bestowed on me as the speaker of prestigious at the onset of 33rd National Convention on Electronics and Telecommunication Engineers. Being an electronics engineer by qualification and working in Indian Radio Regulatory Services, it is indeed a very big opportunity for me to address such an august gathering on the issue of Internet of Things, which is the core of digital transformation for the country. The world has come a long way since the era of late Shri S.K. Mitra, a renowned physicist who had worked immensely in the field of wireless and radio physics. Currently, wireless technologies have come up as an important resource to meet the requirements of network connectivities worldwide. Wireless is the biggest invisible boon of the 21st century, which is connecting people or things invisibly. Internet of Things or IoT is one such field where wireless communication technologies are playing a key role in providing network connectivities. The advent of wireless communication in the 21st century has led to severe engineering challenges concerning interferences and network densification. As we begin to touch the Internet of Things, these challenges are sure to grow. Indeed, it is predicted that the connection densities will surpass 1 million per square kilometer in the near future, largely owing to the deployment of IoT devices and networks. Yet, relatively very little has been done to quantify the network complexities, these networks, and the subsequent implications that these networks will have on this growth will have implications on network performances. According to research from Gartner, more than 20 billion connected things will be in use worldwide by the end of 2020. From connected vehicles to connected homes, Internet of Things or IoT promises the host of benefits for industry and users. But the question is, are we prepared to handle 20 billion connections emanating from plains, desert areas, mountainous regions, and oceans? As we all know, Internet of Things is nothing but interconnection of physical devices. IoT in the country, the success of IoT in the country depends heavily on Internet penetration, and I feel that the need of the hour is to explore new options for enhancing the network capabilities supporting Internet. This challenge is not restricted to big metro cities only, but also to the remote areas where conventional means of communication are yet to reach. According to Internet and Mobile Association of India and market research firm IRRS International, currently the India's Internet penetration is only overall is 31%. With the urban India with an estimated population of 444 million are having only are having 269 million internet users. That is 60%. Whereas in the rural India, with an estimated population of 906 million, as per 2011 census, has only 163 million internet users, that is 17%. Thus, there are potential 750 million internet users still in rural India who are yet to become internet users, if only they can be reached out properly. The engineering fraternity has to face this challenge of digital divide before taking on the IoT movement in the years to come. Apart from terrestrial networks providing connectivity to IoT devices, use of satellite communication can prove to be a game changer. No single company can reach out all the possible markets and customers, handling a flood of connections and amounts of data that will be captured. Keeping in view the ubiquity of space-based communications, satellite technology will play a crucial role in supporting the developments of IoT sector and realizing the full potential of connected devices. Business operations that extend into remote areas rely heavily on satellites to provide communications for facility monitoring and instantaneous asset management for unmanned sites and offshore platforms. This is why satellite operators are investing and collaborating to develop services and hardware that can enable IoT, and at the same time operators are making sure that satellite-based solutions can be easily integrated into hybrid networks that combine fiber, wireless networks and satellites to best serve the IoT and customers at all levels. Machine-to-machine, M2M, communication is paramount for the IoT landscape, and satellite technology is foundational for the development of these technology. As per NSA, there will be 5.8 million machine-to-machine, M2M, and IoT connections by 2023. M2M communication must be reliable. These applications often rely on satellites rather than terrestrial networks, like many consumer-facing devices and applications. Combined with new technologies that generate low cost per bit connectivity, the satellite industry is redefining the solutions it can provide to address the largest communication requirement our world has ever known. With the advent of high throughput Ku and Ka-band satellite connections, the capabilities in orbit have created a broadband superhighway in space, easily handling the potential volume of opportunities in the IoT and M2M sectors. In addition, a new model that combines the advantages of satellites in geostationary orbit with those offered by the constellation of satellites in low Earth orbits will redefine the satellite communication. These hybrid fleets can provide broadband connectivity coverage to the polar region, and they will also be able to layer bandwidth for regions and applications with high density, network density traffic, and as well as for critical applications where redundancy is required. In order to have a major impact, it is essential to make the satellite technology accessible for people or things. This requires innovation throughout the satellite ecosystem to facilitate access while complementing other technologies to enable hybrid solutions. For example, the most progressive satellite operators have made strategic investments with metamaterial manufacturers based antenna technology providers. These partnerships will yield antenna and terminal products not bigger than the size of a laptop in size. They will serve application verticals such as mobility, content delivery, and wireless backhaul. IoT via satellite can play an important role in providing uninterrupted coverage to vehicles. We are just beginning to see the connected cars using cellular networks. The day is not far when we will be using hybrid technologies featuring both satellite and terrestrial technologies. The global nature of satellite communication systems and the ability to broadcast to multiple points is the most efficient signal delivery system on Earth. Satellite broadcast can work seamlessly with terrestrial cell carriers to achieve global coverage and enable auto manufacturers to connect all of their vehicles on a single network. This means that the billions of dollars spent each year by car manufacturers to recall their vehicles for software upgrades could be avoided. Instead, satellites can broadcast these software upgrades to cars on a global basis. Broadcast capabilities of satellites give the strategic advantage both delivering and operating navigation softwares to, and this is essential as we move into the next step. The intelligent cars of future will depend heavily on satellite technology. Terrestrial Wi-Fi and cellular networks support just a portion of the grid that will be required to allow fully autonomous vehicles to navigate city streets and highways. Satellite communications will play an important role in connectivity and autonomy of intelligent cars. An autonomous vehicle requires two different types of signals. Functions of the car like steering and braking that need information about other vehicles along the route must rely on terrestrial networks because with virtually no signal latency because of the time-sensitive nature of these interactions. Other vehicle functions such as navigation that need less time-sensitive interactions. The information can rely on satellite as a medium of communication. The inherent attributes of ubiquity and broadcast for satellite technology. For example, satellites can multicast updates to car concerning road conditions, local imaging of city streets and mapping of selected routes without fear that there is any sudden peak in traffic of wireless networks or any knocks out in response time. When we talk about intelligent cars, there is another big innovation in the agricultural sector. A renowned manufacturer in farming equipment have begun connecting his tractors to the internet and has created a method to display data about farmers' crop yield. Similar to smart cars, The company is pioneering self-driving tractors, which would free up the farmers to perform other tasks and further increase their efficiency. Farmers can use their smartphones, monitor their equipments, livestock, as well as collect stats about their livestock feeding and produce. They can even use this technology to statistical predictions for crops and livestock. The sensors which are placed in fields allow farmers to for mapping and topography and the available resources in their areas and variables such as acidity, temperature of the soil. They can also access climate forecasts, weather patterns in the coming days and weeks. Hence, it will not be too far or too long to think about smart villages having smart farming. Thanks to IoT, the connection between Internet of Things and satellites continues to grow as more and more devices become connected. That link is going to continue to expand, proving the true benefits of satellite technology in the modern connected world. Apart from challenges arising due to technological limitations for IoT movement, there are certain other issues like standardization, interoperability, handling of big data, and cybersecurity. Before we conclude, just imagine a world where we have smart cities, smart homes, smart vehicles, smart environment, smart farming, smart transportation, etc., and huge amount of data arising out of it. The handling of such big data will be the biggest challenge for engineers. The task became even more difficult when we think of handling such enormous data within the ambit of cybersecurity. In this quickly evolving world, all the things that connect to the internet are exponentially expanded, the attack surface for hackers and enemies. A recent study shows that 70% of IoT devices contain serious vulnerabilities. There is undeniable evidence that our dependence on interconnected technologies is defeating our ability to secure it. The industry needs to learn from its mistakes as it innovates and builds devices to function interconnectedly with the internet. Many of the best security practices can be leveraged, such as hardening of the system, using secure protocols for communication or installing updates, fixes and patches. Innovators need to consider that future security will be managed automatically by the system itself instead of users, and designing secure technology will require a new approach and mindset. It is very true that the challenges are multidimensional, but it will be up to the engineers of today and tomorrow to take this IoT movement for the betterment of the country and the world as a whole. It's the time to buckle up, my dear friends. Thanks a lot for giving me such a wonderful opportunity. Thanks.